Exercise 7. This time we're going to construct a right angle triangle. So a right angle triangle is basically a triangle where one angle equates to 90 degrees. So what's the information that we've been given? The base reads at 120 millimeters. And we've also been told that one of the base angles measures at 30 degrees, which means that the opposite angle measures 90 degrees. So let's give this a go. Alright folks, so now let's look at exercise 7. So we've looked at equilateral triangles, so having a triangle where all the sides are more or less equal to each other, and then each angle at the corners equals to 60 degrees. We've also had a look at constructed an isosceles triangle using various techniques. So with the isosceles triangles from fundamentals, it's a triangle that has two base angles and two sides of equal length, still symmetrical. And we looked at a scalene triangle whereby the base angles and the vertex angle or the peak angle are more or less not the same. The size of the triangle has varying lengths. So we had to look at that in exercise 6. We're now going to look at the construction of a right angle triangle where one angle within the triangle equates to 90 degrees. So similar to our set square here. So we've got 60 degrees at this end of the set square, 30 degrees at this end, which means that this angle here should equate to 90 degrees. Okay, so that angle there is 90 degrees, and this 30-60 degree triangle is a scalene triangle, or we can have the other set square which we call a 45 degree set square, where the base angle is 45 degrees, which means that this angle here should sum up to 90 degrees. So in terms of the set squares pair, you do get two 90 degree angles provided. Okay, so we've got that. So what does exercise 7 say? So this time we're being challenged to construct a right angle triangle, base equating to a length of 120, so that will be our AB, and one of the base angles is equal to 30 degrees. So this should be a fairly straightforward affair. So let's start off by scribing our base. So we've got our base, get our compass, and this time we're going to open to 120. So 120, as shown here. We're going to stand at one end, so it's kind of arbitrary. Scribe, stand at where we scribed, scribe to get our B. So this is our A and our B. And then we're going to use our outline to firm these out. So after exercise 7, there's one more exercise relating to triangles. It's going to take a different spin. And I think once I'm done with triangles, I'm going to introduce another concept related to triangles, and it also relates to other geometric forms, and this relates to inscribing, ascribing, circumscribing. So we'll have a play with that in 3 exercises to conclude business relating to triangles, and then we're going to move on to something totally new. Alright, so I could have just simply used our set square, scribed 90 degrees, get the 30 degree set square, stood at B, scribe where the two lines intersect, that completes our triangle. Could easily do that, but I'm not going to do that. I'm going to go through the pain of using construction relating to angles. So I'm going to stand at A, open to a considerable and reasonable distance, and scribe an arc like so. Okay, and I'm going to call the intersecting points 1 and 2. So let me just project that a little bit. Okay, and what I'm going to do is I'm going to stand at 2. Now again, some people tend to use this technique, so you can use this as a reference. So what you can do is you can use the compass, stay at the same radius. Okay, so let's say that's from 2 to A, and I'm going to scribe an arc to cut the semicircle, and I'm going to do likewise. Then at 1, make sure it's open to A, and I'm going to scribe to cut the semicircle. So this is what some people tend to do. So let's call this intersection 3. Let's call this intersection 4. Then what you can do is you can stand at 3, open more than half the chord. Okay, so if we were to draw a line, okay, from one point of a circle to the other, that's basically a chord, right? So open more than half the distance of the chord and scribe an arc. So I can scribe an arc like so, up and down, stand at 4, and do likewise, same distance. Okay, cut to intersect like so. So let's call the point of intersection, let's call that 5, like so. Right? So all I can do, you can use the set square if you don't have a set square. So that's part of the reason why I scribed an arc at the bottom, just in case you don't have a set square, so you can just use your rule. And I'm going to draw a ray through the intersection and point A, so like so. Oops, it's quite faint, so let's double check, like so. So that gives us our 90-degree angle. So let me just put 90 degrees. So this is our 90-degree angle. So we've constructed that. Let me just define the dimension. So just define the dimension like so. Do likewise. There. So we've done our 90 degrees. So if we construct our 30-degree angle here, then that should be enough to project that angle where it cuts with this ray. That forms a 90-degree angle to the base. To the base of the triangle, then that will more or less complete the polygon or the triangle. Sometimes triangles are defined as polygons in some contexts, but we tend to use triangle just to differentiate that from a planar object or a laminar that has more than 4 sides. Okay, so 3 sides triangle, 4 sides quadrilateral, and then beyond that polygons, so your pentagons and your hexagons and all of that, which will along the line will come to learn how these are also constructed. Anyway, back to our construction. So I'm going to stand at B, open to a reasonable distance, scribe an arc like so. Okay, so I'm going to call this cut, so let's call that 7. I'm going to stand at 7, say radius. Okay, so similar to what we've done. So again, it might seem repetitive, but you know, in the event that you do miss those videos, at least in this video, you learn how to construct a 60-degree angle. So I'm going to cut there, but this time I'm not going to draw our 60-degree ray. So where it cuts, I'm going to call that 8. So if I bisect between 8 and 7, that should give me our 30-degree line. So I'm going to stand at 8. Make sure that I've opened more than half the chord from 8 to 7. Scribe an arc like so. Right? Stand at 7 and do likewise. Scribe an arc. Scribe an arc to intersect. Okay. So let's call the point of intersection. Let's call that 9. So I'm going to draw a line from 9. Well, from B through 9, and where it cuts the 90-degree ray, that should complete the triangle. So this is where it cuts, and that completes the triangle. Okay, so we can now firm out the solution. So, then from C to B. Okay, so let's call that our 30 degree. Okay, let's put in some arrowheads in here. And there you have it. So we've now constructed our right angle triangle where we've got a base angle at 30 degrees. So again, let's double check that. So if we've done this correctly, this should equate to 60 degrees. And you see? 60 degrees. So again, there we have it. So hopefully, by going through the construction of triangle series, it's giving you some confidence and understanding in terms of how you can go about using various techniques in constructing simple triangles, simple geometric forms, two-dimensional geometric forms. All right. So the next challenge will be exercise 8, which would be an interesting one because this time we've been given the perimeter. So the total distance around the triangle, and we've been given a ratio in terms of how the size of the triangle has been proportioned. And this will bring us back to something that we've done previously when we started the series relating to geometric and technical drawings. So on that note, I'll see you again for exercise 8. Bye for now.